Now, we have this term called the discriminant, and the discriminant is the actual expression that's found underneath the radical in the quadratic formula. So it's just the b squared minus 4ac. And if you think back to the examples that we just went through, if we simplify that and the solution was a positive number that was greater than 0, we would always end up with two different x-intercepts, regardless of if they were real or rational. And then in the next example, it's simplified where the number underneath the radical, which is called our discriminant, was equal to 0. And that just means that when we have our plus and minus, we're adding 0 or subtracting 0 in the quadratic formula. So therefore, we only have one x-intercept. And if the number was a negative, that means that we have 0 x-intercepts because it ends up being an imaginary number. So it says use the value of the discriminant to describe the number and type of roots. So my a value here is going to be 1, b is equal to 3, and c is equal to 5. I'm going to plug that into my discriminant formula. So this is another formula that you have to know, even though it's derived from the quadratic formula. It does have a different name. We plug in 3 squared minus 4 times 1 times 5, which is 9 minus 20, which is negative 11. So this is a negative number. So if we go back to the sheet, if it's a negative number, that means we have two complex roots. So we would say 2 complex roots. Let's try another one. Our a is equal to 1, our b is equal to negative 11, and our c is equal to 10. We sub that into our formula. Which is 81. So if we have 81, that means that the number underneath that square root is equal to 81. So therefore, if I go back to the chart, it's a number greater than 0, so it's either one of these two. And because 81 is a perfect square, it's two real rational roots. Two real rational roots. So on this last screen, it just kind of goes through different ways to solve quadratic formulas. We can graph them, which we've talked about. We can factor and use the zero product property, setting them equal to 0. We can use the square root property, where we're taking the square plus or minus square root of each side to solve. We can do completing the square and the quadratic formula. All of these are helping us solve the quadratic, and again, when I say solve the quadratic, that means finding the x-intercepts, if there are any.